Welcome to Summarize Science. Today we are looking at a paper titled LeapAlign, which introduces a more efficient way to fine-tune AI image generators. The goal of the researchers was to make models like Flux align better with human preferences and text descriptions. Usually, training an AI to draw better images is incredibly difficult because the process involves hundreds of small steps. To update the AI, computers have to trace back through all those steps, which uses up a massive amount of memory. This often leads to a problem called gradient explosion, where the math becomes so unstable that the training fails. The researchers found that existing methods often ignore the early steps of image generation because they are too hard to calculate. However, those early steps are actually the most important because they determine the basic layout of the image. To fix this, they created LeapAlign, which uses a two-step leap trajectory instead of a long, complicated path. By taking these leaps, the model can quickly jump from noise to a middle stage and then directly to the final image. This simplified path keeps the memory costs low and allows the researchers to update the AI at any point in the process. They also introduced a technique called gradient discounting to keep the training process stable and smooth. Another clever trick they used is called trajectory similarity weighting. This means the system pays more attention to the leaps that are most similar to the actual path the AI would normally take. This ensures that the shortcuts the AI takes during training actually help it create better real-world images. When the researchers tested this method on the Flux model, the results were impressive. As seen in these charts, LeapAlign achieved much higher scores in image quality and text alignment compared to older methods. It outperformed other popular techniques like GRPO and direct gradient methods across several different benchmarks. Look at these comparison images to see the difference for yourself. While other methods might struggle to place objects correctly, LeapAlign helps the AI follow complex instructions accurately. In examples like putting a photo of a horse on a train, the global structure of the image is much more clear and logical. The researchers also analyzed how many leaps are necessary for the best performance. They found that using just 2 steps provides the best balance between high-quality results and computer efficiency. Using more steps didn't actually make the images better, but it did make the training much more expensive. These additional results on the Stable Diffusion 3.5 model show that LeapAlign works on various types of AI architecture. It consistently improves the image quality and ensures the AI doesn't get confused by the prompt. The method is robust and generalizes well to different training sets and reward systems. The final results show incredibly detailed images, from fantasy characters to realistic animals. LeapAlign succeeds by making it easier for the AI to understand what we want from the very first brushstroke. It basically gives the AI a better roadmap for how to transform noise into a masterpiece. To recap, LeapAlign is a new way to train AI using 2-step leaps that save memory and increase stability. This allows the model to learn the most important parts of an image layout early in the process. This breakthrough means we can expect AI images to become much more accurate to our text descriptions. In the future, the researchers believe this method could even be applied to making AI-generated videos more realistic. Thanks for watching Summarize Science, and we will see you in the next one.